What's happening, podcast maniacs? Welcome back to another deep dive where we unpack the knowledge just for you.
Great to be here again, ready to explore another fascinating topic together.
Today, as you know, we're getting into the incredible world of humanoid robots. You brought us a really interesting collection of info on 3 companies leading the charge: Aptronic, Figure AI, and Unitree Robotics.
That's right. We've got comparative analyses, detailed specs on cutting-edge robots like Aptronic's Apollo, Figure AI's Neoline, and the, pretty amazing G1 and H1 models from Unitree Robotics.
So our mission today, listeners, is clear. We're going to pull out the key insights from all this material, compare the strategies these companies are taking, and really try to understand the potential impact of these incredible machines.
Right.
And we'll do it in a way that's clear and engaging without getting totally bogged down in, overwhelming technical jargon. We want you to get a sharp, exciting picture of where humanoid robotics is headed. And to start, I think it's really crucial to understand why the humanoid form is so significant here. It's not just a coincidence that so many companies are going for this shape, is it?
No, not at all. The humanoid form offers fundamental advantages when it comes to interacting with a world designed by and for humans. Think about our tools, our workspaces, even our homes. Everything's kind of built for a specific shape and set of capabilities, so betting on a humanoid robot makes a lot of practical sense.
Perfect. Okay, let's dive in. Let's start with Aptronic and their robot, Apollo. From what we've seen, they have a pretty solid track record.
Definitely. Aptronic isn't a newcomer. They've actually built over 10 robots before this, including NASA's Valkyrie. So just imagine the experience and technical know-how they've accumulated.
Wow, that's impressive. That gives us a good idea of the tech background they're bringing. And it seems like Apollo was designed from the get-go with a very clear vision. A general-purpose robot, easy to use, capable of mass production, handling heavy loads, and importantly, safe to work alongside humans.
Precisely. Their design principles point directly towards mass adoption in commercial settings. Plus, their modular design is really smart. They can put the torso and arms onto different mobile bases, legs for walking, wheels for flat surfaces, or even a stationary base for specific tasks.
Right.
That gives it huge versatility for different jobs.
Okay, and this is where it gets really interesting. Aptronic has formed strategic partnerships with 2 tech giants, NVIDIA and GR00T. What can you tell us about those collaborations?
Well, the NVIDIA collaboration focuses on integrating advanced AI through their project GR00T. What this means, and it's really quite something, is that Apollo won't just be a robot programmed for fixed tasks.
Yeah.
Thanks to GR00T, it'll be able to learn new tasks very quickly just by watching humans do them. Imagine the possibilities for much more complex, adaptive operations in the future. And the GR00T partnership, that's all about large-scale manufacturing. GR00T is a global leader in manufacturing, so this ensures Aptronic can not only develop an intelligent robot, but also actually produce it efficiently and at scale to meet market demand.
That's a really solid strategy. They're not just building the brain, but also laying the groundwork to build lots of them quickly. So talking specs, what details can you give us on Apollo?
Apollo stands at 5'8", 1.73 meters, and weighs about 160 pounds, 72.6 kilograms. Its payload capacity is quite noteworthy. It can carry up to 55 pounds, 25 kilograms. That's crucial for many tasks in warehouses and factories.
Definitely.
It gets about 4 hours of battery life per battery, but the really interesting part is they're hot swappable.
Oh.
This means you can swap them out without shutting the robot down, which theoretically allows for almost continuous operation, maybe up to 22 hours if you have enough charged batteries ready.
That's huge. Really minimizes downtime. And I read something about its linear actuators. What's special about those?
That's an excellent point. Choosing linear actuators instead of the more traditional rotary ones is one of Apollo's distinguishing features. A linear actuator moves in a straight line, like a piston, instead of rotating. According to Aptronic, this offers several key advantages in terms of making the robot easier and cheaper to mass produce, as well as improving energy efficiency and the robustness of their supply chain.
Interesting design choice.
For sensing its environment, Apollo uses advanced stereo vision, similar to our own eyes, plus perimeter and impact zone detection systems to ensure safety when working near people. It also has a wrist with 2 degrees of freedom and a waist with 3, giving it good flexibility for manipulating objects at different angles. And of course, it's electrically powered by those swappable batteries.
So what specific kinds of tasks is this robot actually designed for?
Short term, Apollo is aimed at material handling in warehouses and manufacturing plants. This includes things like picking boxes, unloading trucks, palletizing, sorting, moving containers.
The classic warehouse jobs.
Exactly. It could also handle basic machine supervision. In manufacturing, you might see it doing visual inspections, kitting components, delivering materials to production lines, or even simple subassembly tasks. And thanks to that connection with NVIDIA's project GR00T, the potential to learn and perform much more complex tasks from text, video, and human demonstrations is enormous. Its control software is designed to be intuitive, kind of a point-and-click interface, which should make integration easier. It even has LEDs on its head, mouth, and chest to communicate its status in a more user-friendly way.
A robot that almost gives you a look. And which industries is Aptronic targeting with Apollo?
Initially, like we said, the focus is warehouses and manufacturing plants, which are facing significant labor shortages.
Makes sense.
But long-term, their vision is much broader. It includes construction, oil and gas, electronics production, retail, last-mile delivery, elder care, and even assisting astronauts in space. They're positioning it as a truly versatile robot.
So where are they at in terms of development? When might we actually start seeing these working?
Right now, Aptronic is running pilot programs with actual customers to test Apollo in operational environments. Their initial goal was commercial availability by late 2024, though that timeline might have shifted slightly. The GR00T collaboration is key for scaling production, and the idea that future Apollo robots might assemble more Apollo robots is, well, pretty fascinating.
Yeah, self-replication almost.
And importantly, back in February 2025, they secured a major $350 million Series A funding round specifically to ramp up production capacity significantly. All this suggests Apollo is in an advanced stage with strong momentum towards near-term commercialization.
Okay, let's switch gears now and talk about Figure AI and their Neoline of robots.
Yeah.
The philosophy here seems quite different, right?
Totally. Figure AI has what they call an AI-first philosophy. Their main focus is designing humanoid robots that can basically think for themselves to solve those labor shortage problems we see in many key sectors.
So artificial intelligence is the core pillar they're building on. And what kind of environments are the Neo robots intended for?
They're designed for a variety of settings, both work and, interestingly, home environments. The idea is they can autonomously handle complex tasks in industry and more everyday chores at home. Like Aptronic with Apollo, Figure AI chose the humanoid form so their robots can naturally interact with the human-designed world, placing special emphasis on hand dexterity and efficient movement.
I saw they mentioned several models, Figures 01, Figure 02, Neo Beta, and Neo Gamma. Looks like they're iterating and evolving their designs incredibly fast.
Yeah, that rapid succession of models suggests a very dynamic development process and a high capacity for adaptation. They also pay close attention to safety, using soft covers, and in the case of Neo Gamma, a tendon-driven movement system.
Tendon-driven.
Like our muscles.
Kinda, yeah.
Yeah. Similar to how our muscles and tendons work, this design aims for more natural and potentially safer movements, which is especially important if you consider their long-term plans to put these robots in homes, interacting closely with people.
Focusing on the tech specs, the report details Figure 02 is representative. What can you tell us about it?
Figure 02 is 5 foot 6 cents, 1.68 meters tall, weighs about 154 pounds, 70 kilograms. Its payload is 44 pounds, 20 kilograms, and it has about 5 hours of autonomy, moving at 1.2 meters per second. A really interesting detail is that Figure 02 has 16 degrees of freedom just in the movement and rotation of each hand.
16 per hand.
Wow. Yeah, degrees of freedom refer to the different ways a joint or system can move. 16 in the hand gives it considerable dexterity. While the total body DOF isn't specified, you can infer it's high to achieve the dexterity they're aiming for.
Right.
Figure 01 uses onboard cameras for sensing, while Neo Gamma goes a step further with 4 microphones using beamforming and echo cancellation, plus a 3-speaker system suggesting serious capability for voice interaction. Like Apollo, all Neo models are electric.
It sounds like Neo Gamma is particularly geared towards human interaction. What specific functions and capabilities do Figure AI's robots offer overall?
They're designed to learn and perform complex operations safely for commercial clients, but their long-term vision is much broader, including autonomously doing domestic tasks like washing dishes, doing laundry, unpacking groceries. Yeah. They combine human-like dexterity with advanced AI to operate in sectors like manufacturing, logistics, warehousing, and retail, all facing labor shortages. Neo Gamma, specifically, stands out for its ability to walk naturally with arm swing, squat, sit, manipulate diverse objects even in unknown environments, interact with natural conversation and body language, integrate with smart home devices, and learn from interaction. It even offers a VR teleoperation mode for remote control and learning.
A robot that could become part of the family.
Yeah.
So what are Figure AI's main target industries and applications?
Initially, their focus is on sectors needing automation most due to labor shortages: manufacturing, transportation logistics, warehousing, and retail.
Okay.
But long-term, they aim to enter homes as personal assistants and companions. Figure 02 was already being tested in a BMW factory in 2024, with plans for more units in 2025.
They're moving fast.
Very. For Gamma, limited home deployment is expected in 2025, with large-scale production planned for 2026. Their production goals are incredibly ambitious: 100,000 robots by 2027 and millions by 2028. It shows huge confidence in their tech scalability.
That's a massive bet on rapid expansion. So what's their current development status?
Figure 02 was announced in August 2024, and those BMW factory tests also happened that year. Gamma was at the engineering sample stage as of February 2025, with internal testing already underway in real home environments.
Okay.
Figure AI expects an alpha version of Neo ready for mass production after the third design iteration. They're also running a private early access program for selected users to test Gamma in their homes. Their stated intention is to ship 100,000 humanoids by 2029. It really looks like they're advancing rapidly on both testing and preparing for commercialization in both industrial and domestic markets.
All right, let's turn to Unitree Robotics, a company initially famous for its agile quadruped robots, now making a strong entry into the humanoid space with models G1 and H1.
Correct. Unitree is expanding its product line in a really interesting way. The G1 is positioned as an affordable humanoid platform, mainly for R&D, academia, and education in robotics and AI, but it also has potential for light industry, service sector use, and maybe even home use.
So a more accessible approach, kind of democratizing access to humanoid robotics for research and education. What are the key design principles for the G1?
The G1 focuses on offering great flexibility and wide joint movement angles. It uses AI-driven motion control with advanced capabilities for imitating human movements and reinforcement learning, where the robot learns through experience and feedback. Its relatively lower price point makes it very attractive for a broader range of users and academic institutions.
And what do tech specs tell us about the G1?
The G1's height varies between 1.27 and 1.32 meters, weighing 35 kilograms. The degrees of freedom can range from 23 to 43, depending on the specific configuration. Max knee torque is between 9120 NEM, and its arm payload is 23 kilograms.
Okay, lighter payload than the others.
Yes. For perception, it has a 3D LiDAR sensor and a depth camera. Optionally, you can add a 3-fingered dexterous hand with force control and tactile sensors, plus a 2D OF wrist for better manipulation. Battery life is around 2 hours. It has an 8-core high-performance processor with an option to add an NVIDIA Jetson Orin module for more demanding AI tasks. Its walking speed is over 1.94 meters, which is quite quick, and while running speed isn't specified, you can infer it's significant given the agility of their quadrupeds.
A pretty nimble and versatile robot. What specific functions and capabilities does the G1 offer?
The G1 stands out for its agile, fluid movements, its ability to maintain dynamic balance even in complex situations, and its quick responsiveness. The optional force-controlled hand allows for some degree of precise object manipulation. It can walk, run, jump, and climb stairs. It can also mimic human movements, like those in martial arts and sports, which is really interesting for training and simulation applications. It has potential for light industrial automation, search and rescue in less hazardous environments, basic healthcare assistance, and some domestic tasks. It features AI-driven motion control, giving it high adaptability, and integrates with Unitree's unified large model of robots, Unifull-M, their software platform. They've even shown videos of the G1 doing a side flip.
Wow. Incredible agility. So what are the main target applications and industries for the G1?
It's primarily aimed at R&D projects in universities and tech centers, academic studies in robotics and AI, and educational programs for training future engineers and scientists.
Right, the research focus.
But it's also positioned for use in light industry, the service sector, like internal warehouse logistics, and potentially some home tasks. Possible industrial uses include automating simple assembly line tasks, non-hazardous environment inspections, healthcare support for elderly people with limited mobility, entertainment, and sports training simulations. It's presented as a very versatile platform for a wide range of applications.
Okay, let's move on to the G1's bigger sibling, the Unitree H1. This one really looks like a high-performance humanoid designed for more demanding tasks.
That's right. The H1 is presented as a full-size, high-performance, general-purpose humanoid designed for advanced R&D and potential industrial applications requiring speed, power, and maneuverability.
Right.
Like the G1, it also emphasizes flexibility and wide joint movement angles using AI-driven motion control with imitation and reinforcement learning capabilities. A very important feature of the H1 is that Unitree develops crucial components like the high-torque motors and the 3D LiDAR sensor in-house.
Vertical integration.
Exactly. That vertical integration gives them greater control over costs and helps facilitate mass production of key components. It's a significant competitive advantage.
Definitely. What do the H1 specs look like?
The H1 is about 1.80 meters tall, while a later variant, the H12, is 1.78 meters. Weight is around 47 kilograms for the H1 and 70 kilograms for the H12. Its movement speed is seriously impressive. The original H1 hit a top speed of 3.3 meters, setting a world record for bipedal humanoids.
Record-breaking.
Yeah. The H12 is a bit slower, under 2 meters max, though it's estimated the H1 platform has the potential to exceed 5 meters with future improvements. The maximum joint torques are also very high, around 360 Nm at the knee and 220 Nm at the hip for both models.
Ow.
Vary. The H1 has 23 degrees of freedom, while the H12 has 27, giving it greater dexterity. Both are equipped with a 3D LiDAR sensor and a depth camera for full 360-degree perception. Battery life is similar to the G1, around 2 hours, with quickly replaceable batteries. Processing power comes from Intel Core i5 and i7 processors, with the option for an NVIDIA Jetson or an NX card for advanced AI. The H12 can also be fitted with an optional dexterous hand for finer manipulation.
So a really powerful and fast robot. What specific functions and capabilities does the H1 offer?
The H1 exhibits a very stable gait and highly flexible movement. It can walk and run autonomously on complex and varied terrain. They've shown it performing dynamic coordinated dances and even jumps, indicating a very advanced level of control and coordination.
Dances, I guess.
Yeah. It has great potential for industrial applications needing strength and speed, as well as for assistance tasks at home that require agility. It integrates with an open-source, full-body motion dataset, making it easier to program new actions, and offers teleoperation via devices like Kinect and Apple Vision Pro, allowing remote human control. The ability to perform actions as complex as high-speed running and coordinated dancing really highlights the advanced control and balance they've achieved.
So who is the H1 primarily aimed at?
Primarily, it's targeted at serious R&D projects in universities and tech companies, academic research in advanced robotics, and high-level educational programs.
Right.
However, its use is also envisioned for industrial tasks needing strength and dynamism, like assembling heavy components in the auto industry, search and rescue in hazardous or difficult terrain, and exploring environments dangerous for humans. It's also been used in entertainment and cultural performances requiring complex, coordinated movements. While its initial focus is R&D, the H1 shows huge potential for deployment in various industrial and service sectors needing a high-performance humanoid.
Finally, let's talk about the current development status and availability of Unitree's G1 and H1 models.
The G1 has a pretty competitive starting price of $16,000, and the mass production-ready version was presented in August 2024. The H1's price is significantly higher, around $90,000 for the base model, while the more capable H12 costs $155,969.
That's a jump.
Yeah. Estimated lead times are 2-3 months for the H12 and about 60 days for the H1 after full payment. The H1 was officially launched as the first full-size general-purpose humanoid capable of high-speed running in China, and it got a lot of visibility appearing at the Spring Festival in February 2025. Unitree aims to make humanoids more accessible through cost reduction, as evidenced by the G1's relatively lower price compared to others in its class.
Okay, so we have a really interesting landscape with these three companies. Let's do a quick comparison just to make the key differences crystal clear for our listeners.
Perfect. Looking at the key specs, Apollo stands out with its notable payload capacity, while the H1 clearly leads in movement speed. The G1 is the most budget-friendly option, making it very attractive for research and education.
Battery autonomy for most of these robots falls in the 2 to 5 hour range of continuous operation. Sensor systems also vary, with Apollo and Figure AI focusing mainly on vision, while Unitree incorporates 3D LiDAR for more precise environmental perception.
And qualitatively, what would you say are the main strengths and potential limitations of each?
Apollo shines with its focus on concrete industrial applications, the safety built into its design, and its near-term commercial availability for large-scale logistics and manufacturing. Its main limitation might be battery life, though the hot swap system helps mitigate that.
Right.
Figure AI stands out with its AI-first philosophy and its potential in both industrial and domestic settings, thanks to the advanced AI they're developing, although home deployment is still in earlier stages.
Unitree's G1 is strong on affordability and flexibility, ideal for research and education, but has lower payload and torque compared to Apollo and H1. Finally, the H1 excels in impressive speed and power, making it suitable for advanced research and demanding industrial tasks, though its price is considerably higher and its path to widespread commercialization might be longer.
Looking at their market positioning, it seems like each company is carving out a specific niche to excel in.
Exactly. Aptronic is clearly targeting industrial automation, offering a robust, safe robot. Figure AI is aiming for a broader market, differentiating through its AI capabilities and potential in both industry and the home. Unitree's G1 focuses on making humanoid robotics accessible for research and education, while the H1 targets the high end of research and specialized industrial applications needing dynamic performance.
And regarding the humanoid robotics industry overall, what trends and perspectives are emerging?
Interest and investment in humanoid robots are growing significantly. There are recognized technological challenges still to overcome, like improving dexterity for handling small, complex objects, optimizing energy efficiency for longer autonomy, and reducing manufacturing costs to make them more accessible.
Yeah, the cost is still a big factor.
Definitely. However, the potential market is estimated to be worth several $1 trillion long-term. Advances in AI, more powerful and efficient actuator design, and sensor technology are rapidly driving the field forward. It's highly likely we'll see very significant progress in the coming years.
So to wrap up our deep dive today, what's your short-term and long-term outlook for the future of these humanoid robots we've discussed?
Short term, we'll likely see Apollo making a significant impact in logistics and manufacturing, where the need for automation is urgent. Figure AI's Neo could start influencing both industry and perhaps, more limitedly, some homes as its AI continues to develop and mature. Unitree's G1 will play an important role in research and training new robotics professionals. And the H1 will establish itself as a high-performance platform for advanced R&D and very specialized industrial tasks.
And long-term.
Long-term, these robots have the potential to transform entire industries and society as a whole, automating repetitive, dangerous, or labor-intensive tasks. However, their mass adoption will depend on continued technological innovation, cost reduction, the establishment of clear safety regulations, and public acceptance.
Well, there you have it, Curious Minds of the podcast. We are living through a fascinating moment in robotics history. Humanoid robotics is advancing at breakneck speed, and these three companies we've looked at today are just the spearhead of a revolution yet to come.
Absolutely. It's a field with enormous potential, and it'll be thrilling to closely follow its evolution and the breakthroughs the future holds.
And now, podcast maniacs, we leave you with one final thought to ponder. Given the rapid advancements we're seeing in these humanoid robots, what social or ethical considerations do you think will become most pressing as these machines become more integrated into our workplaces and potentially our homes? Leave your thoughts in the comments below. We'll definitely read them. Until the next deep dive.
See you soon, podcast maniacs. It's been a pleasure sharing this analysis with you.
Until next time. And remember to leave your reflections in the comments. Give this deep dive a big thumbs up if you found it interesting. Subscribe to our channel so you don't miss future dives. And hit that notification bell so you never miss a new episode. Goodbye, podcast maniacs.